Dolby Atmos is an exciting new technology that provides immersive sound. It draws theatergoers into the action without needing 3D glasses. Rather than sending sounds to specific speakers, Atmos allows each sound to be assigned a 3D location in the theater space. When the movie is played back, the sound objects are rendered as closely as possible to their locations, depending on the speaker arrangement of the theater. Harrison has been entrenched as the leader in film mixing since the first PP1 film console was installed at Disney in 1979. Our newest large format console, the MPC-5, implements a series of new features that are optimized for object-based mixing and the Atmos workflow. Atmos presents an incredible new opportunity for film mixing, but it introduces some new challenges as well. Because Harrison focuses on film mixing, our customers depend on us to solve the problems that come with these new technologies. We set out to develop the most fluid, thorough Atmos implementation possible, so you can painlessly adopt Atmos into your workflow. In this video, we will discuss some of the details in the MPC Atmos implementation. If you aren't already familiar with the features and benefits of Atmos, you should first watch our Atmos overview video. You can initiate the Atmos mode by pushing the Atmos button for any channel on the console. Once a channel is switched into Atmos mode, it will be removed from the regular console busing and redirected to the Dolby RMU. The post-fader signal is routed to the RMU's input, and the painting metadata for that object ID, including X, Y, and Z coordinates, are sent to the RMU. The Dolby RMU has 118 object channel inputs. Objects are referred to by their object ID. Any console channel may be assigned to any object ID. The console channel will send the audio and painting information for that object ID to the RMU. There are two different ways to assign channels to an object ID. First, let's investigate the hard assign method, where the user explicitly chooses an object ID for each channel. The object IDs appear in a grid, and you can select any of them that are available. On the Atmos overview page, you'll see that the Atmos object becomes highlighted red to show that it has been hard assigned. If we advance to another channel and try to hard assign it, we will see that the first object has been assigned and is no longer available to us. Film mixes are delivered in multiple stems so that the film can be remixed in various formats and languages without remixing all the elements. For example, a 5.1 mix might be delivered as 3 separate 5.1 mixes: a mix of dialogue, a mix of the music, and a mix of the sound effects. Combined together, these make the primary language theatrical mix, but the DVD might be remixed with higher dialogue, while a foreign language version will have the dialogue tracks recreated in a new language, and it might have a different balance between the music and effects. Subtleties arise with more complicated mixes. If a creature speaks, is that dialogue or sound effects? It should be remixed with the level of dialogue, but it shouldn't be translated. Applying this logic to all of the stems, we find that we may need a lot of them. Dialogue, walla, creatures, Foley, music score, scene music, atmospheric effects, and hard effects. These stems are anecdotally referred to as food groups. Since this is the case with 5.1 mixes, it is also true with Atmos mixes. Every object in the room must be classified into a food group, but how do we make sure that each channel is kept within its group? We've added a new page in iKISS to manage these food groups. The top of the page allows you to name each of the 8 groups. The lower area allows you to drag a range of object IDs and assign them to a food group. Once objects have been assigned to a food group, we see a graphical reminder when we look at the Object ID Assign page. This helps us to remember which objects are assigned to each food group when we're hard assigning an input to an Atmos Object ID. Earlier in the video, we mentioned that channels can be allocated to object IDs in 2 ways. The first way is to manually select the object ID for the channel. This is particularly useful in the early stages of the mix when the tracks might be pre-dubbed and sent back for further editing. We will cover pre-dubs using Pro Tools and the Dolby Atmos plugin in an upcoming video. If you aren't constrained by pre-dub workflow, you might find that it's inconvenient to manage the object IDs yourself, especially if you're trying to maximize the use of the 118 available objects. To avoid choosing an object manually, you can tell the channel to work in dynamic mode. In this mode, the console will decide which object ID to use, and this assignment may change over time as channels are added and removed from the Atmos mode during the mix. This is where food groups get really useful. Let's return to the food group page. Now we're going to tell each channel which food group it belongs to. So the first 48 channels are dialogue, the next 48 channels are music, and the final 48 channels are sound effects. Now, if I jump to a sound effect channel and assign it to Atmos, we can look at the Atmos overview page and see that it was assigned to the first available object ID in the matching food group. This is extremely convenient to us. We no longer have to worry about assigning the objects manually, but we've guaranteed that each sound won't cross over into the wrong food group tracks. If we try to assign too many Atmos objects at the same time, the console will tell us that we've exceeded our limit for this food group. We can either increase the number of objects in the food group, or we can turn off a channel's Atmos assign and return it to the bed mix. In the future, we expect to use food groups for many additional conveniences. For example, we may provide a way to assign a remote group fader to all channels in the Foley food group. In an upcoming video, we are going to demonstrate how to dub the object audio and panning metadata into a Pro Tools recorder. That's the final piece of the puzzle for Atmos workflow. We will also discuss how to use the Harrison MPC console to produce different Atmos, RO3D, and traditional surround format mixes with minimal effort.